And let's jump right in. And we start with the usual. Are there any questions about the upcoming HUG event or anything related to HDF? Anything? Anybody? No? Okay. Then, oh, let's see. There's something here in the chat which I can't see. It's good. Okay, good. Yeah, thanks. Okay, then I will jump right in. What the topic that I chose for today was, and I hope you can see my screen. There was a post on the forum in June, and the author of PureHDF released versions 1 and 2 of PureHDF. The only difference here is that version 2 supports only newer, that is version 6 and 8 of the .NET SDK, whereas PureHDF version 1 supports also older versions of the .NET framework. But in my understanding is that in terms of features, both have the same feature set and so forth. And then he also mentions there he did some benchmarking and so forth, and we'll come to that. So I was very happy when I saw this announcement. And he also mentions a few new things that are now supported in PureHDF, including soft links, opaque data types, object references, and in .NET you can have something, or in many other languages too, you can have nullable value types, and they are supported as well. So we'll come to that in a moment. So yeah, when I saw this, I thought, okay, I gotta try it, and I went in and remember we actually at last year's HUG event we presented an HDF5, a new version of an HDF5 tutorial, and that HDF5 tutorial is available on GitHub under github.com HDF Group HDF5 tutorial, and there are these Jupyter notebooks in here that, in a way, from various different angles, look at a common sort of sample application, and you can run all that using GitHub code spaces, and that makes it easy. So my first thought was, well, let's just pick up where we left. There is a Jupyter notebook here, PureHDF, and I thought, well, let's see, back when I was using PureHDF version 1.0 beta 2, I think, or something like that. So it should be as simple as just updating the package in that, the PureHDF package in that notebook, and see if it still works. So that's what I'm doing here. So I have a GitHub code space already running. This is obviously Visual Studio Code, and I just need to connect to that code space. And I have two code spaces going here, so I want this one. So I'm just connecting to it, and you will see in a moment the project layout, and yeah, that's exactly the same layout as what we see here. It just takes a moment to resume because the code space here just suspends. And yes, and here is that notebook, if you remember. So it's that notebook, purehdf.ipynb, and yeah, the story is still the same. So this is C#. Okay, we know that the Jupyter notebooks support language kernels other than Python, and C# is one of the languages that are supported in what's called .NET Interactive. And I did already these steps. So if you want to run this Jupyter Notebook, as it says here in the instructions, you have to install a VS Code extension called .NET Interactive. I did that. And then using a terminal in this workspace, you have to install the .NET SDK. And here are the instructions. Just run this in a bash shell and off you go. And that's it. So the action starts actually here. So remember last time this would say this PureHDF is distributed unless you build it from source as a so-called nugget package. So the same way you can use pip to install Python packages, and in R you install R packages. So in .NET you use these so-called nugget packages. And in order to install the PureHDF nugget package, you basically say nugget PureHDF and then specify a version here. And as of sometime a few weeks ago, the current 2.x version of PureHDF is 2.1.0. So let's just execute this. And that installs the PureHDF nugget package. And then the same way we import modules in Python, we tell .NET that we want to use this PureHDF package. And I'm not going to go through this, but remember sort of the running theme in this HDF5 tutorial was sort of the simulation of these trajectories from this stochastic process. And it turns out I haven't really checked if there is a version of .NET that supports the normal distribution, but when I wrote this code, I realized that C# programmers seem to be comfortable not having the normal distribution as part of standard .NET. So okay, we can emulate that. And then here is the C# code that basically creates a new data set, decorates that data set with a few attributes, a comment, a link to a Wikipedia article about this particular process, and then since it's a two-dimensional data set, how to interpret rows and columns, and then calibration parameters like the time increment and drift and mean and things like that. And then, so we just run that, and that would create an HDF5 file called OU PureHDF5. So let's run this, and this runs just fine with the latest version of PureHDF, and it creates this HDF5 file over here. And the beauty of this is also that with the H5 Web Visual Studio Code extension, we can sort of inspect this HDF5 file directly in Visual Studio Code. So if we take a line plot, for example, so here we can sort of cycle through. Remember, in this two-dimensional data set, I believe the way we set it up was that columns represent the time step, the logical time step. We have a fixed increment, so time step, I believe there were maybe 1,000, 10 to the 3, 1,000 time steps, and then the rows represent the number, the trajectory. So we create, I forgot already how many trajectories. I believe 100. I think it goes from 0 to 100, but we can dial in a specific trajectory. So if we are fixing or sample path, I think I should say, to look at a specific sample path, like this one, sample path 85, this is what it looks like. Okay, cool. So that still works. So the good news is what worked continues to work. And then I said, okay, the first time I encountered PureHDF, that was sort of in later 2023. In October 2023, I linked the YouTube video here. I put together for the beta version of PureHDF at the time, and then I thought I said, well, let's go back and see if this still works, and maybe even a few new things will work. And so I just added the code from back when to this tutorial because it might be instructive for some users. So just a recap here of the syntax. In C#, we can just create a new file by calling the h5 file constructor, and we have a variable called file that kind of holds that handle. And then it's like a little bit like JSON. It's this block here. This is sort of the scope of that file. So for example, if we want to decorate the root group of that file with an attribute, the way we would do that is we would construct a new attribute, and then we use sort of the key or the dictionary style syntax here, where we just say, okay, I want an attribute called attr1, and it's supposed to be a string, and the value is going to be string attribute. And then likewise, all in the scope of that same file, I want to create a new data set. It's supposed to be two-dimensional. That's the way how you construct a two-dimensional array in .NET with that bracket syntax, and then the number of commas tells you how many dimensions we are dealing with. And so this was this two-dimensional data set that had this test 0, 1 through 9 two-dimensional array. And then we also were interested in what about compound types? Well, and that's again very convenient in C#. You can just create a one-dimensional array of records, and I want to call this data set dset2, and then you can use something .NET C# has this concept of an anonymous record type, where I basically say I'm creating a new record and it has fields A, B, and C, and then the type inferencer, just from the literals here, the type inferencer knows exactly what I'm talking about. So 1 is going to be a 32-bit integer, this is going to be a single precision float, and as you can see here from the IntelliSense, this is a double precision floating point number, and so this is going to be a one-dimensional data set, has a compound type with fields A, B, C of the respective types. But the syntax is very compact, and that's nice. And then just to add to that, C# also has the concept of ragged or jagged arrays, and we can use them to present something that will then be stored as a variable length data type. So this is going to be a one-dimensional data set where the elements are sequences, integer sequences, and this is how you do that in C#. Now, the first new thing we just read in the release notes, that soft links are supported now, and it's as easy as saying, okay, I would like this link to be a soft link, and I want the value of this soft link to be some value. And back when we noticed already, so part of this example was to also create a committed data type. Unfortunately, I just had a brief email exchange with the author this morning, and he said, he doesn't support committed data types yet, and but they might be coming. I mean, it is a feature that is used for people who either would like to document data type use in their HDF profiles, or if you have reasonably complex HDF5 data types, then it's worthwhile just creating that once and putting it somewhere and then just reuse it, rather than carrying around a lot of code that doesn't really solve any problems, but just creates complex data types. So it's then much easier to have it somewhere and keep on using it. And then there was just another variation on this compound data type and a few more attributes and so forth. So that example is here, and if I run this, this just runs and works just fine. So it creates this file called example.h5, and yeah, no surprise here if I switch to this. So all of this works. I think back when I haven't spoken with the authors of H5 Web, yeah, and they know probably they don't handle variable length data types very well at the moment, but okay, you get a degree of information here about the data type in the inspection tab. But yeah, the rendering of the value itself is far from perfect. But I'm sure, yeah, if there's someone in that community that cares about it, they'll follow up on it. The compound types are fine. And this is a hard group 1 and group 2. These are just hard links that link to the same group, and then the same data set shows up twice here, but it's actually the same data set. And then our symbolic link is here as well. So it has the value, some value. So good news. So great. Everything that worked continues to work, and one or the other new thing works. So that's good. And I wanted to do a few more things. Number one is the documentation for PureHDF is actually pretty good. So if you go, it's on GitHub or GitHub.io, GitHub Pages, where you can find the documentation. On one of the pages, yeah, here the overview, there is a feature overview. What struck me, there is mentioning here of multi-threading. We talked about that last time, and we'll look at that in a moment. But it also mentions Amazon S3 access and HSDS access. I have not tried these things. That's maybe for a follow-up clinic. And I haven't really poked around the GitHub repo if there's an example included in the PureHDF GitHub repo illustrating these two things. I remember, if you check the forum, that Vincent is his name, he asked a while ago a question about HSDS and so forth. So I wouldn't be surprised if there were an example in the PureHDF GitHub repo illustrating the use. I'm not so sure about the Amazon S3 access, because this is pure, this is .NET code, C# code. There is no HDF5 library dependence, so he's not going to use the Amazon, the only S3 VFD. There is a VFD-like layer in PureHDF, but I don't think he implemented a version of that. So I'll speak with him and report back next time what he means here by Amazon S3 access. I mean, sure, can you directly issue S3 calls from the .NET framework? Absolutely, from C#, from any of the .NET languages, but yeah, I'm not 100% sure what he means by that here. Okay, that's number one. And then, yeah, the new, I forgot if I have the release notes. He mentions the support. There was actually another page, maybe it was in the original forum post, active.NET benchmark project page. Let me, but the features are actually listed here. No, it goes to the same page. He actually had, I'm trying, I saw a page earlier where he, maybe it was under writing, where he has examples. of how to use object reference. So deferred writing version 1 did that already. Here's a soft link example. Here's a soft link example, and yeah, I used that already in my Mickey Mouse problem. But then there was something about object. There was an object reference example. I'm trying to. I saw an object reference example in. Oh, here we go. Here's the example. So yeah, he supports now object references, and he gives an example. So just create 2 data sets and link them into the HDF5 file. And then in this case, you would create a, so here we have an array of 2 object references, and we assign that. I would imagine, yeah, that creates a data set with 2 elements of type object reference. In fact, it would be demo effect, but just for the fun of it, I could quickly try running that example. If I add this here and copy and paste this, that should actually work. Let's see if I run this. Okay, and then I would say file.write. Let's call this example 1.h5. And if I try running that, here we go. Example 1. And right, here are our 2 data sets. And right, that should be, yeah, of type reference or object reference. Yeah, so that works. Good. Let's see, did I must have, oh, here we go. And then another feature that I haven't tried, so he is trying to support these nullable value types, and he ended up supporting them through variable length sequences, which I'm not sure, I haven't had time to think about that very much, but I'm not convinced that this is maybe the best decision. So yeah, you can create a new HDF5 file and a nullable value, and then you construct a data set whose type is not integer, but if you wish, nullable integer. But of course, HDF5 doesn't have a concept of a nullable element. I mean, you have a fill value or something like that, but you don't really have the concept of a nullable value. And so the decision that he made is then you would create a data set where the element type would be a variable length sequence. And so let's just keep adding to this. We can just add another code block down here. I haven't, don't want this, we want marked, which is code. Now I'm confusing myself. Start, this is code. So let's go in here and, okay, maybe that's just a highlighted issue. File.write, example 2. So let's run this. Okay, something going on here. Shouldn't do that demo effect. Maybe, maybe a semicolon missing here. No, it doesn't like that invalid expression. Okay, I'm not going to spend more time on this. Obviously, more things to try. Let's see, and then yeah, opaque data. That's fine. Fixed length, and then simplifying field mapping. All good. Now I have another workspace prepared, but before I go there, I want to point out that in this workspace, he did quite a few benchmarks, and he mentions this also in his blog post, that in the there is a benchmark subdirectory here. And last time I talked about PureHDF, we looked at the concurrency benchmark where he shows the speed up for multi-threaded reading with PureHDF. But there is a very extensive suite of tests, including compression, filter tests, and so forth here. And he, I can't speak to what all these abbreviations mean. I mean, obviously, it's got to do something with chunking and the version 1 implementation of B-trees, and presumably whether there are filters involved or these chunks are unfiltered, and then what the underlying dimension is, and so forth. But that's just speculation. The interesting thing is he compared the C library. So 110.6, of course, is not the latest and greatest, but one of the better 110 releases. PureHDF, JHDF, remember we had a webinar a few months ago where we learned about JHDF, which again is a Java-based implementation that does not use the HDF5 library, that goes straight to the file format specification. And then Pi5 is the sort of the Python variant of this. There is a pure Python implementation that does not use the library, so it's nothing to do with H5Pi. And he compares the performance of these different implementation. And I don't know what this first set of data points here is about. It's probably just a tag, a release tag. But this is PureHDF 100 beta 2. And then sort of we are interested in version 2 here, PureHDF version 2. So, and it's interesting to see the performance. So oftentimes just the native HDF5 library is a good or the best performer, but then not too far off. Okay, this is a logarithmic scale in this case. So there is quite a factor of difference, maybe a factor of 3 roughly in performance difference for this particular benchmark. But lo and behold, there are situations where the PureHDF implementation is actually faster than the C library. And this is all, no multi-threading, it's single-threaded and everything. So again, I can't speak to what specifically these benchmarks mean, but obviously, there are some filters enabled here. So initially it was unfiltered. Here's something with shuffle and deflate and so forth. So that's actually where we see overhead kicking in from the filter pipeline, because you see here that's a factor of 2 almost between. So we have 21 milliseconds, we have 11 milliseconds here, where the C library with all the defaults and everything is 100 times slower than PureHDF or JHDF, or, well, Pi5 is a little slower than that in between. And likewise here, so I guess, these are different filters, or I don't know what he means. Maybe single chunk is a 1 chunk, but a large chunk. But even there, PureHDF is already faster than the C library, and then that here the C library is faster. I don't know what he means by implicit. I gotta check. Then fixed array. Okay, so these are different chunk layouts. There are optimizations in the library. for chunk indexes. So it's not always a B tree, it could be a fixed array, and there are some other options. So here the C library is actually pretty good. But then fixed, I don't know what he means by fixed array paged. That might be one of those options, but there is actually quite a dramatic difference where pure HDF, or sort of the difference between pure HDF and 110.6 is probably a factor of 20, if I read that correctly. So that's interesting. And then, okay, yeah, extensible array, that's another one, another of these indexing options. Okay, the native library is doing pretty well here, likewise here, but then here in this case, extensible array secondary blocks, pure HDF is probably 10, no, not quite 10 times faster, but almost. B-tree version 2, okay, so that's pretty good, again, for the C library. So some interesting numbers to pour over here and to understand, yeah, how he implemented it and why that is and so forth. So a lot of material to go over. And then maybe in the interest of time, I'm not going to go over it, but the nice thing is if you want to run some of these benchmarks yourself, what you can do is, the nice thing these days is just create a code space, and I have one running here, so I can quickly disconnect from this one, and do you want, don't save, and connect to that other code space, and just show you, it's basically everything in a code space for .NET repo happens through the .NET command. So I have this code space here, and I'll just connect to it. And yeah, that's just spinning up, and I'll just open a terminal. And okay, here we go. And so, yeah, that takes you, this is now in the pure HDF main repo, the master branch or main branch. And then, so in here, you can just say .NET build, and then typically you would specify a configuration. So for example, the release configuration, you would just build that. And yeah, that just builds, and it builds all the dependencies. And then if you want to run specific benchmarks, you can go into benchmarks, and there are two sets of benchmarks here. One is the concurrency benchmark. I ran that last time, but I can quickly run it again. So you would just say .NET run, and that should be it. And right, so that just creates a test file that he uses for reading chunks concurrently from that data set. I forgot already if it was something like 10 megabyte or 100 megabyte chunks. And once that's done, right. So yeah, if we run it with 4 threads, so you see a speed up of 4, and then he runs it with memory map files, and so that's all good. And but then for the other benchmarks, pure HDF bench, then you can run, and this is very long running, but I'll start it anyway. .NET build dash C release, and that builds these benchmarks, and then you can run them, and that they create sort of the web pages, including the web pages that you just saw. .NET run dash C and then you have sort of, yeah, you can select different, but if you want to run all of them, then it just goes out and starts these test runners, and then you will get some output, and then everything gets collected in these. There is an artifacts directory here, and all the log files and web pages and so forth get dumped in here. And yeah, it also gives you plenty of diagnostic output along the way. So that's, I think, all I had for today. So exciting times. It looks like this is a great project, and he found the time to really take this to the release level. Again, it was in beta in last October, and a year later we have 2 release versions, 1 and 2, where 1 is really just for the older, in double quotes, .NET frameworks, whereas version 2 targets the newer .NET 6 and 8. And so, yeah, I think it's fantastic. And so if you have use for .NET in your environment, and let's say you want to already take advantage of multi-threading. By the way, in the feature list, he lists also support, for example, if you have compression that can take advantage of hardware. I'm not sure if you mean CPUs, but GPUs, but certain instruction sets on certain processors and so forth. That's all supported. And yeah, so I think it's a great project that continues to amaze and surprise, and I want to keep an eye on it. And yeah, if I have more time, I can dig into the meanings of these specific benchmarks and how to maybe explain these differences in performance, mostly between pure HDF performance and the unmanaged library. I mean, I doubt, I'd be surprised if there was a big difference if this were 1.14. I forgot what we are up to, 3 or 4. I don't think there would be a huge difference here. But nevertheless, yeah, for the situations where pure HDF seems to be so much faster than the HDF5 library, I think it would be interesting to understand why that is. Anyway, that's all I had. Thank you. Questions?
Gerd, I had a question. I don't know if you've covered this with him, but on his documentation site under the APIs, he does have a namespace for pure.vol.native. So is he is part of the focus here to provide the vol interface in this implementation?
I'm not sure. I mean, I think yes, in the sense, I think he tries to provide an equivalent, because obviously the API is not the HDF5C API, it's sort of a C# API.
Yeah.
But I think he realizes the value of having having this abstraction where this extension layer effectively, where if you are targeting sort of the non-default storage or any kind of other storage, including a web service of some sort, then that's worth replicating in pure HDF. And I believe that's what he did here. So for example, if you look at, here's actually the BFD Amazon. So he must have done something similar. Interestingly, so maybe I can extend the HDF5 tutorial to cover these two. I just didn't notice that this was included in the documentation. But yeah, here you see you just make a connection to an HSDS endpoint, and then yeah, once you have that connection, pretty much everything else just follows the standard pure HDF way of doing things, creating files, adding attributes, reading attributes, and so forth. So yes, I think this is a very long-winded answer to your question. Yes, I think he tries to have a comparable extension layer in pure HDF, where you want to pretty much maintain the API, but completely abstract away what kind of storage or backend you are targeting. Okay.
Yes. Yes. And the other thing I would just add real quick is Alexander had pointed out that one of the reasons that the Python interface was really so successful was because through also its use of NumPy, it created this very Pythonic view of HDF5 that sort of didn't exist before. And in your demo here today, it looks like this is very similar in that it uses a lot of real native C# type of programming constructs that in a way does almost an equivalent thing for C# that Python did in its own way. So it's interesting. There's an interesting analogy there, I think, from a usage perspective.
Yeah. And I think that, that's one of the things why, you better leave it to the experts of a particular language to develop the idiomatic and otherwise language bindings or complete re-implementations for that language, rather than having people who know how to program C perpetuate C into other languages, and that just has happened too many times. But then on the other hand, I think we learned that lesson, and we're not doing that anymore. And this is just a good example where it's got to feel like programming in that language for people who are proficient in programming in that language, and that language being C# in this case.
Yes, and nicely done.
Yeah. So I think, and he did that all himself, and sort of the whole way from the file format specification. And I remember asking him a few times whether there are clarifications and things, that improvements that we could make to the file format specification that he had to figure out himself. But I'll ask him again if there are any improved. But otherwise, he did it all the way from the bits and bytes on disk all the way up to the dwindling heights of C#. Yeah.
Okay, thanks, Gerd.
All right. Good. Well, thanks everybody for coming, and everybody remember Hug next week in Chicago, and still a chance to either attend in person or online. We'll see as many of you there as possible. And Lori just pasted the link to Hug in here.
Yep, and we will not have a Call the Doctor session next week, as we will all be in Chicago. So we are Call the Doctor people in 2 weeks.
Okay.
Thanks, everyone.
Good. Thank you. Bye.